versions of the cosine of 2 theta. So we'll be using those. We'll be using power reducing. So anytime you have a sine squared or cosine squared or a tangent squared, how to reduce those so that the squareds aren't there. And then half angle formulas, and you'll see when we get to there the context in which those are used. So, just like we've been doing, if they give you the sine of an angle or the cosine or the tangent, draw it. So theta is in quadrant 2. The sine of it, opposite over hypotenuse, is 5/13, which means the missing side length is what, Nate? Careful. Good. -12. Now, to find the exact value of 2 times, or the sine of 2 times theta, we're just going to use the formula, but there's some thoughts I want you to have. If theta is in quadrant 2, where is 2 times theta? Because theta being in quadrant 2 means it's somewhere between, and we'll do degrees because I know most of you are more comfortable with that, it's somewhere between 90 and 180. Which means if you double it, it's somewhere between 180 and 360, correct? So it's either in quadrant 3 or 4, I just don't know which one. But regardless, sine in either of those quadrants is always what? Negative. So I do expect a negative answer. You don't have to process all that. The formula will make that all happen. But the sine of 2 theta from your double angle formula above is 2 sine theta cosine theta. So your 2 is there. Your sine of theta is 5/13. You can either reprocess that by doing opposite over hypotenuse, or you can just pull it from what they gave you. And the cosine of theta is adjacent over hypotenuse, so -12/13. So when you multiply across the top, you get -120 over 169. Good? The cosine of 2 theta, we can use any one of the 3 formulas. I'll use cosine squared theta minus sine squared theta. So the cosine of theta was -12 over 13, and we have to square that. The sine of theta was 5/13, and we have to square that. So I get 119 over 169. Now that one was a little bit different because double theta would have been in quadrant 3 or 4. We really didn't know if it was going to end up being positive cosine or negative cosine. But now that we realize that the cosine of double theta is a positive number, we know that that was in quadrant 4 once you doubled it. And then lastly, the tangent of 2 theta, 2 tan theta over 1 minus tan squared theta. Go ahead, evaluate that on your own. Mitch, what'd you get? Oh, you didn't finish it. Unless you're stuck somewhere, then you can just at the end. Okay, send your paper over. Wait, did you grab his paper? Sarah, what'd you get? Anybody get anything different? Sarah, bring me paper. Joey, what'd you get? Negative 120 over 119. Anybody get anything different? Okay, negative 120 over 119 is correct. So I'm going to show you Sarah's first. So 2 times the tangent of theta, which she used negative 5/12, over 1 minus the tangent squared of theta, 1 plus 5/12. And comments. What did she do wrong? Krista? Okay, so you never squared the tangent of theta, right? You just did 1 minus the tangent of theta. So you did 1 minus negative 5/12, which became 1 plus 5/12. So when you square negative 5/12, what should you get? 25 over 144, and that minus sign is still there. There is no double negative here because you square first, turns it into a positive, and then you have to clean it up from there. John, will you send that back to him, please? On this one, okay, so 2 times negative 5/12 would be negative 10/12, and you lost your negative sign. The 1 minus 25 over 144 looks good. And then, can you tell me what you're doing from here to, oh, you got a common denominator here? So like 144 over 144 minus 25? So wouldn't that be a positive 119? But honestly, that's not an issue because you made this one negative when it should have been positive. And remember, that one was supposed to be negative and you made it positive. So there's your 2 wrongs sometimes do make a right, Mrs. Rayhill. And then keep change flip, so 10/12. And then, so you're trying, this is why. You don't have a calculator, but you're trying to multiply these and then reduce, maybe? You're trying to do that. If you just, this is multiplication, so the 12 and the 144 can reduce, and there's your negative 120 over 119. So try not to multiply huge numbers that you don't have a calculator for. Okay? All right. On the next one, if you see this on your paper and you're looking to evaluate it, your first thought would probably be like, I have no idea because I don't know what the tangent of 15 is, right? There are 2 ways that you can do this. Number 1 is, let's see, actually there's like several ways you can do this, and I'm trying to think of where your heads will be at when you're on a test, when you have lots of different options to choose from. Your initial reaction has to be, I don't know what the tangent of 15 is, so there's got to be another way. The easiest way is to realize the similarity between that and that. It is your tangent of 2 theta formula, where theta has just been replaced with a what? 15. So if I'm going backwards, this equals the tangent of 2 times 15 then, which is the tangent of 30, obviously, and that is a value you should know to be root 3 over 3. Okay? Now, that might be something that you don't recognize. And you might think, okay, well, 15 is half of 30. So if you go up to this half angle formula, if you wanted to find the tangent of 15, alpha would have to be 30. So within my numerator, this way is going to be harder, but within my numerator, I can replace that tangent of 15 with the tangent of 30 over 2, and so that would become plus or minus the square root of 1 minus the cosine of 30 over 1 plus the cosine of 30. Do we follow? Okay. So now, because my angle is 15 degrees, there's a plus or minus in front of it because it kind of depends on where your angle is. So is the tangent of 15 going to be positive or negative? Positive. So I'm going to use the positive square root of 1 minus the cosine of 30 over 1 plus the cosine of 30. All over 1 minus, now there's two ways I can do this one. I can take my tangent of 15, which I already did, and just square it, right? Does that make sense? And if I take this tangent of 15 expression and just square it, the square root and the square are going to cancel. And by the way, if you saw that tangent squared, you also, so see that tangent squared 15, you could also use the power reducing. Tangent squared of 15 would be 1 minus the cosine of 2 times 15, so 1 minus cosine 30 over 1 plus cosine 30, which is what this is going to be anyway when you square that square root. So just a lot of different options which can become overwhelming, but they all work. This one's just going to be a lot harder to simplify because the cosine of 30 is root 3 over 2, and so you're going to have to clear that fraction, the complex fraction, then take the square root of it, and there will be a complex fraction down there as well, and then simplify. So there are easier ways to do things, and so like even though there's multiple ways, usually one definitely trumps the others as far as being easiest, and that would just be the recognition of what we did first time. Okay? So I'm going to save us the hassle, and I'm not going to go through all that, but it would work out if you did it properly, but doing it properly is the big asterisk. All right, verification. So we're proving again. So this is something that is new to us, the cosine of 3 theta. We don't have any 3 thetas on here, correct? So how could we think of the cosine of 3 theta and change it into something that will make something on here useful? Any ideas? How could we break it up? Aiden, take a guess. So say that one more time. But you wouldn't introduce that second theta. Because the cosine of 2 theta, the way you just said that, which is the way I wrote down, this plus that does not equal the cosine of 3 theta. But you've got the somewhat of the right idea. We're just going to change 3 theta to 2 theta plus theta in parentheses. So now we can use the sum of cosines formula. You see it? Andrew? If you did the cosine of 6 theta over 2, I'm trying to think if I can in my head think steps forward. Yes, but then the problem is if you do the cosine of 6 theta over 2, this is 6 theta in here. And are you going to be able to evaluate the cosine of 6 theta? Do you know what I mean? If it's we kind of use those more when there's numbers involved, that you're trying to find the cosine of some number that you don't know. But this one will allow us to use the cosine sum formula. Cosine of something plus something. So that'll be cosine cosine minus sine sine. So cosine 2 theta cosine theta minus the sine of 2 theta sine theta. Then within those, you have your double angle formulas. Yes? Okay. Now, as far as the double angle formulas, with the sine of 2 theta, you don't have any option. That is what it is from your reference sheet. The sine of 2 theta has to be replaced with 2 sine theta cosine theta. Which you can foresee it. I don't want you to change it now, but you can foresee that that's going to be 2 sine squared cosine theta, right? And then here you do have an option. The cosine of 2 theta, you have 3 different options for. Keeping in mind that you want a cosine cubed to come up, which one do you think would make that happen? Whatever you plug in there is going to have to be multiplied by cosine theta, right? So a cosine squared, so either one of the first two times a cosine will make a cosine cubed pop up. There might be some trial and error here. We might try one, and just for the sake of starting one, I'm going to try the first one. Cosine squared theta minus sine squared theta times cosine theta. In which case I would have to distribute cosine cubed theta minus sine squared theta cosine theta minus 2 sine squared cosine theta. That's not bad because these are combinable, right? I got minus 1 minus 2. So that would be cosine cubed theta minus 3 sine squared cosine theta what do we have? We've got a sine squared in there on the left. We don't really want a sine squared. Can we agree with that? Look at your final answer. You don't want a sine squared, so we will need to substitute that out and replace it with something so that we can get rid of our sine squareds altogether. So in hindsight, now that I realize I don't want a sine squared in my final answer, I probably shouldn't have chosen that one. I probably should have, hold on, I probably should have chosen this one. And so now I can either count my losses and go back and change that, or I can replace the sine squared there with like an identity of some sort. So we'll pick up with that one tomorrow. Let me think about your homework here quickly, because I don't know if I want you doing identities. Give me 1 second. Why don't you just do, let's say, skip. Just do 1 through 21 odds. Numbers 1 through 21 odds.